I'm Marcus Fleury. I'm a faculty at Washington State University, and I'm specialized in soil physics, Wadowstone hydrology. In terms of this research project that we have here on biodegradable mulch, we are looking at the effect of these different biodegradable mulches on soils. When we apply those mulches to soils, we might expect that soil quality over time will be affected by these mulch applications. So our specific objective is to see how long-term mulch applications will affect the functions of soil, how soil functions, and we quantify this by assessing different soil quality parameters. We do that here in the field, as you can see in my background. So we'll do different types of experiments to assess soil physical, soil biological, soil chemical parameters.
One of the biggest concerns that farmers have about using biodegradable mulches is their impact on soil quality. So in addition to all the soil quality measures that we took in the field, we're also looking at how these mulches are affecting the microbial communities in the soil. So we're interested in the bacteria and the fungi that live there and if they're changing as a result of using these materials. We're going to be investigating this using DNA-based approaches. So we take soils, extract DNA, look at the sequences to identify what the communities look like. So when it comes to analyzing the microbiology of the system, we're looking at samples from both Washington and Tennessee. There's a lot of site differences between these two places, different soil types, different chemistry, different environments. And all of these things can influence microbial communities and what types of microbes are in the system. So we want to see how these mulches are affecting the microbes in both these places. So one of the biggest questions in using biodegradable mulches is what is the fate of these mulches? There's a huge advantage to be able to till them into the soil at the end of the growing season, but we really need to understand where they go. So this involves understanding the mechanisms by which they're being broken down by microbes. So one of the things we're going to be doing in my lab is isolating microbes that can degrade these mulches and better understand the biochemical and genetic pathways that are behind that biodegradation. Essentially, we're trying to put the bio into biodegradation. We're also going to be looking at the outputs, so the carbon compounds, the byproducts of this biodegradation. These will be collected from the soil itself and also through the use of lysimeters, which collect soil pore water. By looking at the carbon compounds that are in this soil pore water, we can see what sort of byproducts are coming out of the mulch. This is a really important question because growers have cited concerns that tilling into these materials into the soil may leave residual compounds or residual materials, and they're concerned about that. So another approach we're taking to understanding the biodegradation of these materials in soils is done in conjunction with the plastics working group. We're going to be running a series of lab experiments where we alter environmental conditions to see how it affects microbial breakdown of these materials. So the plastics working group will be responsible for measuring changes in the material strength and the properties of these materials, whereas we'll be looking at the microbial activities and how they're breaking down these materials. It's really a transdisciplinary approach to understanding the mechanism and the fate of these biodegradable mulches in soils.
In the context of sustainability and sustainable agricultural practices, and one of the major goals of sustainable agriculture is to accumulate soil organic matter in soils on a year-to-year basis. So we are interested in seeing if these biodegradable mulches are helping to accumulate soil carbon, which is a very important component of soil organic matter overall. And we hope to be able to isolate some of the specific physical and biological processes that might be the mechanisms controlling that accumulation of organic matter. Is looking more at the microbial community as a whole. So these decomposers of soil organic matter and mulch material, are they changing the types of substrates they're utilizing? And can we tell if they actually are breaking down mulch material in a large enough amount to make a difference at the field scale? Can we measure it in the amount of CO2 coming out of the soil? Can we measure it in the bulk enzyme activity? We don't expect to see results in soil organic matter in the first couple of years, because that's a large pool of carbon and nutrients in the soil, and it takes time for us to see those results at a large scale.